For 30 years, scientists have told you the same thing. The universe isn't just expanding, it's speeding up. Some invisible force is stepping on the gas, pushing galaxies apart faster and faster, forever. That discovery won the Nobel Prize in Physics in 2011. Then, in November of 2025, a team of astronomers said, "We were wrong. The universe isn't accelerating anymore. It's already slowing down." And if they were right, it would have rewritten the ending of the universe itself. For 7 months, that claim stood. Cosmologists argued about it. Headlines called it a paradigm shift. Then, in June of 2026, a different team went back and checked the math. And what they found wasn't a flaw in the universe. It was a mistake in a spreadsheet. Before we get into that, if you enjoy videos like this, go ahead and subscribe, like, and share this one. It genuinely helps the channel grow so I can keep making videos like this. Before we get to the mistake, you need to understand what's actually at stake here, because this isn't some obscure academic argument. This is about the single biggest unsolved mystery in physics. Here's the background. Back in 1998, two competing teams of astronomers were trying to measure how fast the universe is expanding. To do that, they used something called a Type 1a supernova, a very specific kind of exploding star. Here's why these explosions are so useful. A Type 1a supernova happens when a white dwarf star siphons material off a companion star until it hits a very precise mass limit, and then detonates. Because every one of these explosions happens at almost exactly the same mass, they all explode with almost exactly the same brightness. Astronomers call them standard candles. If you know how bright something is supposed to be, and you measure how dim it actually looks from Earth, you can calculate exactly how far away it is. When both teams did this for thousands of galaxies, they found something nobody expected. The most distant galaxies weren't just moving away from us, they were moving away faster than the closer ones. The expansion of the universe wasn't slowing down under its own gravity like everyone assumed. It was speeding up. Something was pushing back against gravity itself. Nobody knew what. They just gave it a name: dark energy. That discovery won the 2011 Nobel Prize in Physics, awarded to Saul Perlmutter, Brian Schmidt, and Adam Rees. For the 27 years since that original 1998 discovery, dark energy has sat at the center of our entire model of the cosmos. Then, in 2025, a team led by astronomer Young-Wook Lee at Yonsei University in South Korea published a paper that shook that foundation. Lee's team had noticed something in the DESI data. That's the Dark Energy Spectroscopic Instrument, a project that had just built the largest 3D map of the universe ever made. DESI's early results had already hinted that dark energy might not be constant, that it might be weakening over time. Lee's team took that idea further. They studied 300 galaxies containing Type 1a supernovae and found something specific. Supernovae from younger stellar populations appeared systematically fainter, while supernovae from older populations appeared brighter, even after standard brightness corrections. In other words, the standard candles weren't as standard as everyone thought. Their brightness depended on the age of the star that made them. If that's true, it changes everything. Because if some of that dimming we've been measuring for nearly 3 decades wasn't actually caused by cosmic acceleration, but by the age of the exploding stars themselves, then maybe the acceleration was never really there. Maybe we misread the data from the very beginning. Lee himself described it as a universe that has already entered a phase of decelerated expansion, and said that if confirmed, this would mark a paradigm shift on the scale of the original 2011 discovery. This wasn't a fringe claim from an unknown lab. It was published in the monthly notices of the Royal Astronomical Society, one of the most respected journals in the field. And it landed right on top of DESI's own hints that dark energy might be weakening. Two independent lines of evidence apparently agreeing with each other. For months, this was treated as one of the most serious challenges to modern cosmology in over 2 decades. Then came June 2026. A new study, led by Dr. Phil Wiseman at the University of Southampton, went back through the exact same kind of data. And this time, the author list included 2 of the biggest names in the field, Adam Rees and Brian Schmidt, the same 2 scientists who won the Nobel Prize in 2011 for discovering the acceleration in the first place. Their conclusion? The universe is still accelerating. Dark energy is still there. And the 2025 result wasn't a flaw in the cosmos, it was a flaw in the calculation. Here's exactly what they found. Lee's team had made a quiet but critical assumption that the age of a galaxy is the same as the age of the star that exploded inside it. That sounds reasonable until you remember that galaxies contain stars of wildly different ages, born at different times from different generations of stellar material. Treating "how old is this galaxy" as a stand-in for "how old is this specific star" introduces a bias. On top of that, the 2025 analysis hadn't properly accounted for the mass of the host galaxies the supernova exploded in, another factor that affects how these explosions actually look. When Wiseman's team went back and corrected for both of those factors, properly calibrating for the different host environments and stellar populations, the evidence for acceleration came back, consistently, robustly. Rees put it simply: extraordinary claims, he said, require especially careful testing. And when his team ran that testing properly, the evidence for cosmic acceleration held up. Wiseman was even more direct about it, saying plainly that the crisis had been averted. So, dark energy is real. The universe is still speeding up. Nearly 3 decades of cosmology didn't just get quietly walked back. Here's the part most headlines miss. This wasn't science getting embarrassed. This is what science is actually supposed to look like. Co-author Mark Sullivan summed up the whole episode in one line: "This is how progress is made." Even though Lee's specific idea didn't hold up, it forced the entire field to go back and re-examine assumptions about how supernovae explode and how we measure the universe. Assumptions that, it turns out, needed rechecking anyway. Another co-author on the rebuttal, Brody Popovich, described it as a chance to revisit every assumption baked into the measurement and confirm, carefully, that it still holds. That's the actual value of an extraordinary claim. It doesn't just get proven or disproven, it forces everyone to check their work more carefully than they ever would have otherwise. Dark energy is a more carefully verified idea today than it was in 2025, specifically because someone tried to knock it down and failed. But, and this is important, nobody solved the actual mystery here. We still don't know what dark energy is. We only know, with more confidence than before, that it's there and that it's still pushing. That's really where this leaves us. The universe is still accelerating, forever, into an ever colder, ever darker future. We just don't know why. And for now, that's exactly where nearly 3 decades of cosmology said we'd be. So the next time you see a headline claiming scientists proved dark energy doesn't exist, or that some new paper just rewrote the fate of the universe, remember this one. Because in cosmology, an extraordinary claim doesn't get to just stand there unchallenged. It gets tested, retested, and torn apart by people with Nobel Prizes and nothing to prove except whether the math holds up. This time, it held up. If this kind of video is something you want more of, go ahead and subscribe, like, and share it. It really does help the channel grow and keeps these videos coming. And this actually isn't the only time this exact thing happened this year. Just a few weeks before this, a completely different team announced they'd found evidence that the universe itself isn't smooth the way we've always assumed. That on the largest scales, it's clumpy, uneven, almost stringy. If true, it would have broken one of the oldest assumptions in cosmology. It took less than a month for someone to find the mistake in that one, too. So if you want to see the next extraordinary claim get put through the ringer, that video's coming very soon. Make sure you're subscribed so you don't miss it.